Okay, so for this video, we are going to discuss the second part of this chapter where we are going to use all the discrete random variables for testing. All right, so discrete random variable here, it includes actually the binomial and Poisson. All right, the word discrete here, it will include the Poisson and also the binomial distribution that you learned before. All right, so first of all, let us start with the testing a population proportion. So population proportion means you want to test the P lah. In the previous type of hypothesis test, when you use normal distribution, right, we are testing the population mean. That means the mu. So for this one, we are going to test on the population proportion P, and we will consider small sample size for now. Alright, so what's the learning outcome for this part? They want you to formulate a hypothesis and carry out a hypothesis test in the context of a single observation for a population where a binomial or Poisson distribution is being used. Alright, and then for now, for this population proportion, we are going to use binomial to test it. Okay, then you also need to consider the case where you can direct use the binomial to run the test, or sometimes in some certain circumference or certain condition you need to have the normal approximation. That means in some certain condition, right, you actually need to change binomial become normal. So when you are running the test, okay, when you are carrying out the test, actually this concept also applies. All right, but no matter how, we'll discuss it slowly, step by step. Okay. All right, so let's start with our explanation in the notes. Okay, so if let's say I want to know whether a coin is biased or fair, okay, then you can carry out a test to see whether the proportion of getting a head is equals half or not. So if it is equals to half, then the coin is fair. So if it is not equals to half, so that means it is not fair. All right. Okay, so this will be your null hypothesis, and this is your alternative hypothesis if you want to carry out the test. All right, so when you want to carry out the test on the P, so you see we are not using mu anymore. In this case, we are testing the P, the population proportion. Okay, so when you want to run the test, right, you need to calculate the probability of the observed value or more extreme value by using binomial distribution. Okay, and compare the probability with the significance level. All right, so here I try to summarize some steps which is quite important for you to follow when you want to carry out a test for population proportion. All right, so you can see step number one again, which is very similar. You are using the same concept to form the null and alternative hypothesis. All right, so how to write out the correct null and alternative hypothesis? We already learned it at the beginning of this chapter. Then the same thing happen here is the rules to decide the null and alternative are the same, just that now we are not going to test the mu anymore. In this binomial distribution cases, we are testing on the population proportion. So you can see that all the symbols here are P, not mu anymore. That's the first thing. Okay, so this is first step. All right, so the second step is you need to calculate the probability. So actually this probability, we also learned it before, right? Okay, in short, this probability, we call it as p-value. Okay, so that's why in the previous types of tests, I actually suggested you that you have to learn both methods, which is critical value and also p-value approach. Because for this discrete random variable, right, you cannot use critical value approach. You can only use p-value approach. All right, so this probability that you calculate later will be the p-value. And then from the observed or more extreme value. So usually the observed and more extreme value, right, they will be given in the question. Okay, usually they will be given in the question, like what is the value that you should use to calculate the probability. Okay, and after that, you need to calculate the probability, then you compare it with the significance level. So significance level will be given also in the question. After that, you need to make a decision for step number 4, and then you need to make a conclusion. So for this part, usually some students will memorize it, but for me, I don't like to memorize. So later I will ask you to draw a simple diagram to help you to identify and make a decision as well. Alright, so in general, this is what we have for our test here. So you can see that the steps are more or less the same, but the details I can only discuss it with you when we are using some example. Alright. Okay, so let's continue with example 13. Okay, you can read the question first before we start. Okay, so there's a drug company produce a new type of drug now for migraine sufferer and stated that the drug has a 90% success rate. So when they say 90% success rate, means that you are having P equals to 90%, which is 0.90. So this is the information that you can get from this first sentence here. So a doctor doubt. So doubt means that not really believe whether the drug would have the successful rate as the company claim. So he's thinking that the rate might be lower. So when you see this keyword is the keyword to tell you to form the correct alternative hypothesis. So since it don't really believe, so that means that when you are writing it out in a symbol form, it will be P smaller than 0.90. Right? Okay, so 0.90. Alright, so from here very obvious already like which one is alternative and which one is null. Okay, then after that, the doctor prescribed the drug for 15 of her patients. So now they are talking about the sample data that they are going to use to run the test. Okay, you are having 15 patients. After 6 months, 11 of these said that their migraine symptoms have been relieved by the drug. Okay, so 11 of these say that has been relieved by the drug. Okay, so this 11 itself is this 11 is the observed value, or we call it as extreme value, observed value, or you can call it as extreme value. So you have to look for this observed value from the question. Okay, and then how about the 15 here? Okay, so for binomial distribution, okay, you are using a smaller sample to calculate the probability, right? So this 15 is the n. Okay, so the 11 will be the observed value. So 11 out of 15 patients, something happened. So from here, you can see that it is a binomial distribution style. All right. Okay, then after that, they want you to test the company's claim at the 5% level of significance. So this one is also the, how to say, the alpha, okay, that given by the question itself. So you're going to use it later when you want to make any decision. Okay, so we will start here for step number 1. Okay, so step number 1, they want you to state the null and alternative hypothesis. So very easy. You have null hypothesis and alternative hypothesis, and you already identified just now, right? So we are having P equals to 0.90, and then P smaller than 0.90. Alright, so again, as what I said, I would prefer to write out a sentence about the alternative hypothesis. So I will write out the statement here, the success rate, okay, of the drug is less than 0.90, or you can write 90%. So this is my very first step here. Okay, you already formed the null and alternative hypothesis. Okay, then now you could proceed to step number 2. So for step number 2, they want you to calculate the probability of the observed or a more extreme value. Okay, so to calculate this p-value here, the probability here, you need to calculate lah. Okay, first, because of you know that you are going to test about the population proportion, right? So we are using binomial to run the test. So you have to write it out first. X is binomial distributed. What is the n? You are using a sample of 15 patients. And after that, the probability here for the success rate is 0.9, right? You assume that this is a correct one, 0.9, the p. Okay. Then they want you to calculate the probability. So you want to calculate the probability that x and then 11. Okay, so now we are having a problem here. For this 11, you have a few signs that you can put in. Smaller, equal, or greater equal, or smaller or greater. which is the correct sign that you should put in. Okay, so first of all, here, this kind of all this sign here, the explanation I can only write it like this. I can only explain to you in terms of the example. All right, so please make sure that you are clear about this part. Okay, so when you want to find out the probability, right, it can be either smaller, smaller, equal, greater, equal, or greater. Most of the time, when they are talking 11 of this patient, right, it includes the 11. Therefore, usually our sign will have the equal sign. So the no equal sign one usually will not be considered the sign. Okay, then now we have two options now. We left two options now. Should I put it smaller, equal, or greater, equal? Okay, all right. So one of the easier way is this one. You look at your alternative hypothesis, it is smaller, right? So you just follow the sign for the alternative hypothesis, which is smaller, equal. So for this example, to calculate the p-value, the sign that you put should be smaller, equal. All right, so this is how you determine it. All right, therefore, if you want to look at the alternative hypothesis sign to decide your sign for the calculation of the probability, right, you have to make sure that the sign for alternative hypothesis is correct. If let's say you write it out wrongly, then definitely all your calculation later will be wrong. So that's the first thing. Okay, so this is the first method, which is more straightforward in my opinion. So you can try to use this method. Another method to decide the sign here is you have to compare the sample value with the mean, the observed value with the mean. So as an example, what is the mean for binomial? So the mean for binomial is n times p, right? Okay, so when you are using n times p, which is 15 multiplied with 0.9, what you will get 13.5. Okay, so you can imagine on the number line, mean is 13.5, and then this value 11 is on the left hand side of 13.5, right? Because on the number line, this value should be larger, so 11 should be before the mean 13.5. So when you want to calculate the probability, we usually calculate the probability by the side one. By the side means that I want to calculate the probability for this part, so which means it should be smaller, equals to 11. So this is another way for us to decide the sign for the calculation of p-value. Okay, so there are two methods here. Alright, so maybe some of you will think that this method, the second method, is actually harder and more troublesome. Indeed it is, but it will be useful for two-tailed test. Because for two-tailed test, right, this one didn't have any sign. It is non-equal sign lah. So you actually, from the non-equal sign, you are not sure. You will not be sure whether you should put a smaller or larger. So this will be very helpful in two-tailed test. Okay, but at least I show you here first, then you see how we decide. Okay, all right. So once you decide the sign already, then you can start to calculate the probability. So you need the basic common sense on binomial distribution. Okay, so x smaller equals to 11 means that you need to calculate from 0 until 1, 2, 3, 4, 5, 6, 7, 8 until 11, right? Which is very long, the step. So you can take 1 minus 12, 13, 14, 15. So 12, 13, 14, 15 means 15, C 12, then 0.9 power 12, 0.1 power 3. Then minus again 15, C 13, 0.9 power 13, 0.1 power 2. Okay, and also 14. And then 15. All right, so after you calculate the probability here, you will get the probability 0.0556. And this is what we call it as p-value. Okay, So for this p-value, we completed the second part, step number 2. Okay, all right. So the formula here, for the formula here, you need to write out at least once for the binomial formula. Here I write out 4, right? 15C12, 15C13, and so on. But if let's say you feel very lazy, then you can skip, but you must write out at least once the formula for the binomial distribution. Okay, all right. So now we already at step 2. Then now we proceed to step number 3. So for step number 3, they want you to compare the p-value with significance level. Okay, so to compare the p-value with significance level, last time we will draw a normal graph, right? Then the normal graph you will have maybe the rejection region here. For this case, because smaller, okay, then only you decide where you put your p-value. Okay, the area is larger or smaller whatsoever. Okay, so now because this question itself is not a normal distribution, therefore you are not allowed to draw this normal graph, because this normal graph is for normal distribution only. All right, so but I still want to use the same method by using the diagram to help me. So for me, I will just draw a very simple simple line or simple bar. All right, so at the simple bar here, this is 0 and this is 15. Okay, this is the value of x. So x equals to 0 until x equals to 15, because of my sample here using is x until 50. Okay, then after that, I will need to draw the significance level first, 0.5%. Oh, sorry, 5%, which is 0.05. Okay, so where this is actually your rejection area. So for this one-tailed test, right, your rejection area should be on the left-hand side, right? Look at the alternative sign. So your rejection region is on the left-hand side. So I will draw this one first, and then you need to know this red color area itself is 0.05. The area itself lah. Okay, all right. Then after that, because you calculate the p-value just now, right? So now p-value is 0.0556. So the area 0.0556 should be more than 0.05 or less than 0.05. So definitely it's more than. So you can see that at this line, where x equals to 11, okay, so this particular area, it's very hard for me to do it like that, so I will just maybe highlight it. Okay, so this area from 0 until 11, the probability itself, okay, so the probability itself is 0.0556. So if you compare the highlighted area and the shaded area, right, so the highlighted area should be a larger one. Okay, then you look at this 11 here. So the 11 falls outside the rejection region already, right? Because only the red color part here is the rejection region. So 11 falls outside the rejection region. Therefore, it is in the acceptance region. Okay, so since you already know that it falls under the acceptance region, you can make a conclusion now at step number 4. So the step number 4 is decision, which is to not reject the null hypothesis. Okay, so you can make a conclusion saying that the drug company's claim is justified or supported. So this is your conclusion. Or if your conclusion, you can write it also something like the success rate of the drug is actually less than 0.09 or 90%. Okay, so here the steps doesn't look very long, but there are a lot of small details that you need to know. So this is the first step that we have. Step number 1, form alternative and null hypothesis. Step number 2, write out the binomial distribution symbol here. And after that, you try to calculate for the p-value. Third step is this one. You draw a simple graph and then you compare your p-value. P-value means the area with the significance level. Then you can make a decision for part number 4. Okay, so part number 3, purely you draw the, you draw the graph to help you the diagram. Then this is step number 4 and 5, make a decision and also the conclusion. Okay, so for step number 3, you will realize that in most of the marking scheme or whatsoever, they actually didn't draw this out. They will just write out a statement. So if you want, you can also write out a statement like this to justify it. So you can see that the p-value, okay, so you can write like this. So you can write the p-value is greater than significance level, which is 0.05. Then you do not reject the null hypothesis and the drugs company claim is justified. So most of the book, they will only write out the statement to clarify it. Alright, so for me, I draw it out is because of at least I can see it clearer in a clearer way, that very obvious the 11 falls under the acceptance region. So from there I make a decision and conclusion. Alright, so this is what we have for our one tail test left hand side for binomial distribution. So again, we are testing on the population proportion. Alright, so this is example 13. So I want you to try example 14 on your own, then later you double check the answer in the PDF file that I will upload later. Alright, so I will stop here for this video. Then next video we are going to discuss others example on binomial, which is maybe one tail test on the right and also the two tail test from this part.